Okay, hi everyone. We're going to attempt to do this lecture thing. So, chapter 10, gases. Um, so first of all, pressure. Pressure is just the amount of force over a given amount of area. So girls, this is why it's a lot harder to walk in stiletto high heels than it is to walk in wedges, because in a stiletto, you have all that same weight, but going into a very, very tiny piece of the shoe versus like a big chunky heel or wedges. It's that pressure, that force is spread out over a greater area. So, that's what pressure basically is. Then you have your gas laws. All of these should be review. So P1V1 over T1 equals P2V2 over T2. And then Avogadro's law, PV equals nRT. And that if it's at STP, it occupies 22.4 liters if you have 1 mole of a gas. And that's of any gas. It doesn't have to be anything specific. It can be methane or neon or oxygen or anything you want it to be. Okay. So this should also be review. 2 balloons of the same volume are at the same temperature. Are they different or the same? So number 1, the pressures of the gas in the 2 balloons are equal. They're going to be the same because if they're at the same volume and the same temperature, they have to be at the same pressure. Number 2, the number of moles of the gas in the 2 balloons are also the same because if they're at the same volume and the same temperature, then you're going to have the same number of moles. The densities of the gas in the 2 balloons are different because density is mass over volume. So density depends on the mass. Helium and hydrogen are going to have different masses. And so even though the volume is the same, the pressure is the same, the number of moles is all the same, the density is still going to be different because they have different masses. I'll show you the simulation when I get back, but the kinetic molecular theory explains the behavior of gases on a molecular level, right? Because kinetic molecular is just the way that molecules are moving. So you've got the ideal gas law. Now, there's a little trick here. For N, you can replace that with mass over the molar mass, okay? And then you can rearrange that equation in order to find density. So the way we can do this, hold on. Okay. So if we are looking for density, that's grams over liters. So what that really means is that you need M over V, right? So if you were to plug this in for N, then you're going to have PV equals, let's see, M over M. Oh God, this looks so ugly. RT, right? That should be a P. Oh my God. Okay, so when you do this, try to get lowercase m and capital V over at the same side. So when you end up doing this, you should have, let's see, P and then M over RT. And then you just solve for that. So pressure times the molar mass, let's see here, divided by R times T. And you have all the information that you need in order to do that. So hopefully that helped. Okay, moving on. Oh, now do that half sheet. Ask the sub for the half sheet. Pause this and then come back when you're done.